Alright, today we're in the 5.4 day 1, doing examples 1 through 3, sum and difference formula. Essentially what we're trying to do is we're trying to find the exact value of the cosine of 75 degrees. Okay? Cosine of 75 degrees is not our common angle, it's not a 45, it's not a 30, it's not a 60. Therefore it makes it a little bit harder. But 75 degrees is a compilation of two things. 75 degrees is 45 plus 30. So I can rewrite this as the cosine of 45 degrees plus 30 degrees. And there's a formula for this. And the formula states the cosine of u plus v is equal to the cosine of u cosine of v times the sine of u sine of v. And not times, it should be plus right there. Okay, I stand corrected. It actually should not be a plus, it should be a minus. That should be a minus right there. I apologize for the error. That should be a minus. Minus sine u sine v, and that's the formula for it. Okay, well in this situation, 45 degrees is the u, 30 degrees is the v. So I'm going to plug these things in, and so it's going to be the cosine of 45 degrees times the cosine of 30 degrees minus the sine of 45 degrees times the sine of 30 degrees. I'm going one step at a time, nice and slow. The cosine of 45, if you have your circle in front of you, it'll make this a lot easier, is square root 2 over 2. The cosine of 30 degrees is square root 3 over 2. The sine of 45 is the square root of 2 over 2. And the sine of 30 is a half. And so square root 2 times square root 3 is square root 6. 2 times 2 is 4. Square root 2 times 1 is square root 2. 2 times 2 is 4. And this simplifies to the square root of 6 minus the square root of 2 over 4. So that is the exact value of the cosine of 75 degrees. Okay? Let's do one with sine. Sine of pi over 12. I'm going to erase a little bit so I have some more room here on the board. So if you need to press pause to catch up, go ahead. Sine of pi over 12. Well, pi over 12 is not one of our common angles. It's not a pi over 3, a pi over 4, a pi over 6. But I know that pi over 3, which is 1/3, minus pi over 4, which is a fourth. If I get a common denominator, it would be 4/12 minus 3/12, and that's 1/12, or pi over 12. So the sine of pi over 12 can be written as the sine of pi over 3 minus pi over 4. So I'm going to use the formula, the sine of u minus v, sine of u minus v, and that's equal to the sine of u times the cosine of v minus the cosine of u sine of v, like that. And these formulas are on your formula reference sheet under sum and difference formulas. So they're right there for you to look at. Put the numbers in where they go. Again, the first one is considered to be u. The second one is considered to be v. And so this becomes the sine of pi over 3 times the cosine of pi over 4 minus the cosine of pi over 3 times the sine of pi over 4. Sine of pi over 3 is square root 3 over 2. Again, you can get that from your circle on the formula reference sheet, or you can do triangles, opposite over hypotenuse. Cosine of pi over 4 is 1 over square root 2. I'm going to use this form, or actually what I'd probably use instead is the simplified form, square root 2 over 2. Minus cosine of pi over 3 is a half. Sine of pi over 4 again is square root 2 over 2. So square root 3 times square root 2 is square root 6 over 4 minus 1 times square root 2 is square root 2. 2 times 2 is 4. Simplifies to the square root of 6 minus the square root of 2 all over 4. And that's up on your screen now. So the sine of pi over 12, the exact value is that. Okay? Let's work through number 9. Number 9 together. It's kind of a tricky way to prove that this actually works. But essentially it says take the cosine of 240 minus the cosine of 0. It wants you to use the difference of the cosine formula. So I believe this is cosine u, cosine v, plus sine u, sine v. I might be inaccurate, but I believe that to be correct. So the cosine of 240 is negative 1/2. The cosine of v, or the cosine of 0, is 1. And then plus the sine of u is, I'm not for sure what the sine of 240 is, top of my head. Let's take a look at that. On sine 240, enter. So it looks like negative square root 3 over 2. The sine of v, or the sine of 0, is 0. And so you get negative 1/2 plus 0, so you get negative 1/2. Then it tells you to do the same problem essentially in part B, but it tells you to find the cosine of 240 to be negative 1/2 minus the cosine of 0, which is 0, and you get negative 1/2. So really number 9 is just proving the idea that this formula works since you get the same answer twice. Okay? So that's how you do number 9. Let's actually try one where you got to do some work here. Sine of 75 degrees. Try this one on your own. Well, first thing I would notice about this, if you're a little stuck, is that 75 degrees is the same as 45 degrees plus 30 degrees. I made a sum problem out of two common angles that I know, 45 and 30. And so I would suggest that 45 is the u, 30 is the v. And so now I write down the formula. Sine of u plus v is sine of u, cosine of v, plus cosine of u, sine v, like that. So it'd be the sine of 45 degrees, cosine of 30 degrees, plus cosine of 45 degrees, sine of 30 degrees. Sine of 45 is square root 2 over 2. Cosine of 30 is square root 3 over 2. Plus cosine of 45 again is square root 2 over 2. Sine of 30, I believe it would be 1/2, so times 1/2. That gives me square root 6 over 4 plus square root 2 over 4, which is square root 6 plus square root 2 all over 4. And that's the exact value for the sine of 45 degrees. Okay? That's how you do it. Let's move on to example 2. You gotta do a little thinking here. It says, find the exact value of the sine of u plus v, given the sine of u is 4/5, where 0 is less than u less than pi over 2, and cosine of v is negative 12/13, where pi over 2 is less than v less than pi. Well, let's interpret this problem a little bit at a time. Let's start with the easy part. U and v are two different angles. U is in quadrant 1 because it says it's between 0 and pi over 2. V, however, is in quadrant 2 because it's between pi over 2 and pi. So there's the first part to interpret where the angles actually are. Okay? So now, my formula says that I'm trying to do this, and so it says sine of u, cosine of v, plus cosine of u, sine of v. Okay? Well, I already know the sine of u. The sine of u is 4/5. And I already know the cosine of v. The cosine of v is negative 12 over 13. What I have to figure out is I have to find out the cosine of u and the sine of v without giving those things. Well, this is what you have to do. For u, draw a triangle that involves u. There's u. Sine is 4/5, opposite 4, hypotenuse 5. So what's that tell me about the missing side? Well, It's a common triangle, a 3, 4, 5, or you can do 25 minus 16 is 9, square root of 9 is 3. So that tells me the cosine of u is 3/5 because it's adjacent over hypotenuse. So there's a cosine of u. Okay, to find the sine of v, draw a triangle, label an angle v, know that it's 12 for adjacent, 13 for hypotenuse. We're looking for b here. So square the hypotenuse, square the other side, subtract it, and you get 25. Therefore, b is 5. Since this one's in quadrant number 2, we determined that already. It's in quadrant 2. The sign is positive, so it would be opposite 5 over hypotenuse 13. And it looks something like that. Now I'm just going to multiply the fractions together and add the two fractions. So it looks like I get negative 48. 5 times 13 is 65. Plus 3 times 5 is 15. 5 times 13 is 65. So negative 48 plus 15 is negative 33 over 65. And that is the exact value of the sine of u plus v with the given conditions. Okay? Press pause, see if you can figure out number 49. If not, you'll know I'll come back here and try to help you out in just a second. Okay, we're back. Again, the sine of u is 5/13, so that tells me quadrant 1. The cosine of v is negative 4/5. That tells me it's either quadrant 2 or 4, or quadrant 2 or 3. Probably quadrant 2 would be my guess, based upon the directions and what I have written in my notes. So we're trying to find the sine of u plus v, and that again is equal to the sine of u cosine v plus cosine u sine v. So there's our equation we have to fill out. Sine of u we know, 5/13. Cosine of v we know, negative 4/5. Now I have to find the cosine of u and the sine of v. So I'm going to draw a triangle for u. There's u, hypotenuse 13, opposite side 5. So 13 squared is 169, 5 squared is 25. I subtract, get 144. That means this missing side is 12. So the cosine of u is adjacent 12 over hypotenuse 13. Now we're going to try to find the sine of v. So v, adjacent 4, hypotenuse 5. That means this missing side is 25, or 5 squared minus 4 squared is 16, or 9. So the side missing is 3. The sine is opposite. So times opposite 3 over hypotenuse 5. Okay? Put this all together. 5 times negative 4 is negative 20 over 65. Plus 12 times 3 is 36. 13 times 5 is 65. For a total answer of 16 over 65. Question is, if this would reduce, should I? And the correct response to that is yes, you should reduce this if possible. Okay, now if you think about it, I think we made a mistake somewhere. Can you figure out where it is? Well, according to the back of the book, the answer here is negative 56 over 65. Which means that's negative 36 over 65, which means that should be negative 3 over 5, because I believe that u and v are both second quadrant angles according to the directions. I kind of missed that part, so that should be negative 12/13, because both these in the directions say second quadrant angles. Apologize for that, but that's what you get. Example 3 here. Write the cosine of the arctangent of 1 plus the arctangent of cosine of x. Cosine of the arctangent of 1 plus the arc cosine of x as an algebraic expression. Alright, so we're going to use, this is a u, we'll call this u, we'll call this v, the cosine of u plus v. Well, the cosine of u plus v is the cosine of u times the cosine of v minus the sine of u times the sine of v. And we don't have any of those things to start out with already. None whatsoever. Okay? So for u, I'm going to draw a triangle. Since it wants to know the arctangent of 1, so 1 is opposite over hypotenuse. So we know this is square root 2. So we know this to be 45 degrees. So u is a 45-degree angle. There's u. So I need the cosine of u. The cosine of u is 1 over square root 2, which is square root 2 over 2. Like that. Well, yes, that's true for our purposes, though. Let's just leave it 1 over square root 2. For the sine of u, again, u is here. That's opposite 1 over square root 2. So I have that so far. Now let's talk about v. Alright, got triangle. This is x. I want to know the arc cosine of x. Or sorry, the angle is v. The arc cosine of x means x is the adjacent side. 1 is the hypotenuse because of the x over 1. How do I find this other leg here? Well, the cosine of v is pretty simple. It's x over 1. Sine of v is opposite, so I need that opposite side right there. And so my Pythagorean theorem tells me that's x squared plus b squared equals 1 squared. So x squared plus b squared equals 1. B squared equals 1 minus x squared. B equals the square root of 1 minus x squared. So that would go right here. So what this means is 1 over square root 2 times the sine is the opposite, square root of 1 minus x squared, over the hypotenuse 1. Multiply this out to get x over square root 2 minus square root of 1 minus x squared over square root 2. Common denominator is square root 2, so it's x square root 1 minus x squared all over the square root of 2. And we're just going to leave it just like that because we can. Challenging problem, yes, I agree. Try to rewatch it, see if you figure out what's going on, and then try out number 57. Okay, so we should by now know, we should be able to label u and v. U's the first one, v's the second one. Since it's the sine, we should call it sine of u cosine v plus cosine u sine of v. We should be able to write up the equation. They're both x's this time. So my blue triangle is going to be my u triangle. It wants to know what value of u has a sine that's equal to x. And so x would be the opposite side, 1 would be the hypotenuse. Based upon what we did in the last problem, x squared plus the base squared is 1 squared. So b squared equals 1 minus x squared. B is the square root of 1 minus x squared. So 1 minus x squared square root. That gives me the triangle for, let me write that again a little neater to help you out a little bit. That goes right there. That's what we need to know. That goes right there. So we can do the u parts. The sine of u is x over 1. Cosine of v we don't know yet. Cosine of u we don't know what yet. Sine of v, we do know the cosine of u. It is adjacent, square root of 1 minus x squared over 1. And now we got to do v. Angle v. X is the value of the cosine, so the cosine would be adjacent x over hypotenuse 1. And so this is again going to be square root of 1 minus x squared. This works out that way. So the cosine of the cosine of v would be x over 1. The sine of v would be opposite, square root 1 minus x squared over 1. Multiply this out. I'm going to get x times x to be x squared, plus multiply these two together, it makes the square root sign disappear, so it's 1 minus x squared. And the final answer is going to be just 1. Nice problem. Alright, ask questions if necessary. Remember the assignment for 5.4 day 1 is located on the assignment page in the folder, okay?